Hello guys, welcome to my video installment of Chapter 2, Part 3, right? So in Part 2 we finished up with velocity and speed, and so now we're going to be talking about another key aspect of this chapter, which is called acceleration, okay? So what you want to think about when you hear acceleration is change in velocity, okay? So it's kind of the change, which is represented by this delta here, the change in v, okay? And so since this incorporates a velocity term, since acceleration incorporates velocity, it is a vector. It is a vector, and that was my phone if you heard it. So change in v, you want to think of acceleration like that. So acceleration basically measures how fast the velocity of an object is changing. So if let's say the car's moving down, if a race car is moving down the track, okay. Sorry again, not a very nice car. Wow, it's kind of short on the wheels here. I'll give it 8 wheels, okay. So let's say it's moving down the track, all right, and like here it has to go around like turns and stuff. Like it has this big like track. It has this big loop to go around, right? Okay. So it's constantly turning. So it's constantly changing velocity because it's also changing its speed sometimes. Sometimes it's a slow around down the turns. So the acceleration measures how fast it goes from 30 meters per second here, right? Like acceleration is basically how fast it goes from 30 meters per second to like 50 meters per second, okay? And so that's kind of what you want to look at when you see acceleration is change in velocity. Let me emphasize that. Change in velocity. That's acceleration. That's the key aspect of acceleration. So now we're going to go, I'm actually going to go to another, well actually let me illustrate one more topic for you. You want to know about acceleration, that it doesn't refer to speed. Acceleration is not a speed, okay? It doesn't refer to speed. It refers to how fast v changes, okay? How fast velocity changes. This is key, guys. This is key up here, okay? So now I'm going to go to actually another. Actually, let's talk about one thing real quick. One more thing. So free fall. So now we're going to talk about objects falling. So if you have like a ball here falling, it's going to go down. Right? It has downward motion. Wow, that was such a bad straight line. It has downward motion, right? Just because of gravity. Okay? And so now in real physics, in real life, there'll be air resistance, resisting it, just air. There's air molecules resisting it, and it will slow it down a little bit. But when we're talking the physics that we use, we're assuming that there's no air resistance, okay? No air resistance. So when an object falls only due to gravity, only due to G, it is in free fall. So since we're ignoring all this air resistance, this guy's in free fall. Straight down free fall because we're assuming no air resistance, okay? And so now in free fall, we want to, so acceleration due to gravity. So when something is in free fall, when an object's in free fall, it's going to have the same, gravity has the same acceleration, right? It has a constant acceleration. So what we want to realize is that acceleration due to gravity is always equal to, sorry, it's an equal sign, is always equal to 10 meters per second squared. Technically it's 9.8, but for our purposes we're using 10. Okay, so it's always, so g acceleration is always 10 meters per second squared. Okay, so this guy's going to be accelerating at 10 meters per second squared throughout his whole flight because he's in free fall. Okay, now if he were to hit, you know, big, like maybe a gust of wind, his acceleration would change, right? But that's not the case here. So now I'm going to move to another page here, over here, so you can see my beautiful drawing here. So this is kind of an illustration here of a ball. Okay, the ball's starting here. Right here it's at 0 seconds. Okay, 0 seconds, as you can see, and right here it's at 1, 2, 3. Now the main equation for falling objects right here in free fall, mind you, in free fall, is velocity is equal to acceleration due to gravity times the time. So we know that G always equals 10 meters per second, right? We just figured that out. That's the acceleration due to gravity always. So let's plug in some numbers. So what's the velocity? Maybe what's the velocity of this ball here? If you want to know how fast this ball is traveling at 0 seconds, it hasn't started falling yet. Well, let's plug it in. Velocity is equal to 10, right? G times 0, and we all know that is 0. So at 0 seconds, it's at 0 meters per second. Okay. Now at 1, let's plug it in. V is equal to 10 times 1 is 10. So 10 meters per second, right? Now 2, we're just going to go expedite it a little bit. 20, and 3, 30 meters per second. So for every elapsed mean past second, velocity increases by 10 meters per second. See that? Because acceleration due to gravity is always 10 meters per second squared. Got that? This is key physics right here. So, you know, you can rewatch this video, but you're going to have to get this. You're going to have to know this very well. That when you go from here to here, it's a 1 second time difference, and so it's a 10 meters per second, 10 meters per second velocity change, and here and here, right? So that's key. So I'll see you guys in the next video, which will be more on moving projectiles and acceleration.